Hi guys, we are going to find the value of the above series. If we draw our attention to the denominator of each term in this series, they are the sum of an arithmetic series of integers. Suppose we have an arithmetic sequence of integers 1, 2, 3 till integer n, then sum of its n term will 1 plus 2 plus 3 till integer n will be defined as Sn equals to n by 2 into 2a plus n minus 1 into d. Where n is total number of term, a is the first term of the sequence which is equals to 1, and d is the common difference between two consecutive terms in the sequence, as 3 minus 2 is 1, 2 minus 1 is 1. So d will be equals to 1. Now we simplify this Sn by putting the value of a and d in this formula. So Sn will be n by 2 into 2 into 1 plus n minus 1 into 1, as d is equals to 1, which is equals to n by 2, 2 plus n minus 1 is equals to n into n plus 1 by 2. Hence, sum of n integers will be defined as Sn is equals to n into n plus 1 by 2. If they are term 1, it will be defined as S1. If they are two term, 1 plus 2 will be defined as S2. If they are a 3 term, then summation of 3 term 1 plus 2 plus 3 will be defined as S3, and so on. Now we replace the denominator of each term in the series as summation of arithmetic series. So first term will become 1 upon 1, 1 as a S1. Second term is 1 upon 1 plus 2. So 1 upon 1 plus 2 is S2. Third term is 1 upon, denominator is 1 plus 2 plus 3, which is equals to S3. Fourth term will become 1 upon S4, and so on. And the last term will become, as the summation till term 2024, it will become as 2024. Now we will write the summation in sigma notation. So it will become sigma n start from 1 to 2024. 1 upon Sn. Now we will put the value of Sn in this expression. So it will become sigma n start from 1 to 2024, 1 upon Sn, which is n into n plus 1 by 2. N into n plus 1 by 2. Now this 2 will go to the numerator. So it will become sigma n from 1 to 2024, 2 divided by n into n plus 1. As 2 is constant, we can factor out it from sigma. So 2 sigma from n to 2024, 1 upon n into n plus 1. As the denominator of this fraction has two linear factors n and n plus 1, we can split this fraction into two small fractions such that the denominator of each fraction will contain linear factor. So I will explain it. So I can write it as a two fraction, and each fraction will contain these linear factors. Into, and sigma is from n equal to 1 to 2024. So by simplifying this two factor, what we get? C is n into n plus 1. N plus 1 minus n is cancel out 1 upon n into n plus 1. The original expression. So we can write 1 upon n into n plus 1 as 1 upon n minus 1 upon n plus 1. I further simplify this. So 2 into bracket sigma n start from 1 to 2024 1 upon n minus sigma n start from 1 to 2024 is 1 upon n plus 1. Now by expanding this summation, so first term when n equal to 1 it become 1 upon 1 plus when n equal to 2 it become 1 upon 2. When n equal to 3 it become 1 upon 3 and last term will be 1 upon 2024. This is a minus. Now I am expanding this expression. So when n equal to 1 it become 1 upon 1 plus 1, 1 upon 2 plus when n equal to 2 it become 1 upon 2 plus 1 is 1 upon 3 and so on, and last term when n equal to 2024 it become 1 upon 2024 plus 1 is 2025. So when I open this bracket, so each term will become negative as negative is outside of the bracket. So if I open this bracket it becomes minus 1 by 2, minus 1 by 3, minus 1 by 4 so on till minus 1 upon 2025. We can see the all term between 1 upon 1 to 1 upon 2025 will be cancelled out. So what is left? 2 into 1 upon 1 minus 1 upon 2025, and further we simplify it and get 2025 as a LCM. It becomes here 2025 minus 1 which is equals to 2 into 2 2024 divided by 2025. 2 into 2024 is 4048 divided by 2025. So this is the sum of the given series. If you like this video, please subscribe to my channel. Have a lovely day.